I want to thank you for the lesson, too.
Sure.
I liked during the huddle how you helped make them accountable for being good listeners or for continuing to do their own thinking, because you would like ask somebody to explain something, and then sometimes you would stop and not let them explain and have everybody else try to say, why did you put them together? So I just thought that was a nice mix of keeping everybody actively engaged in what was going on during that, sort of abnormal routine for them. And I liked how they didn't just go sometimes just with like all the equal signs. So like I think one of the first, maybe it was the third group that came up there, they had one expression or one equation that had an equal sign in it, and then they had 3 expressions, and they put them all together, and they were quite comfortable having those all together. And even when you sort of pointed it out to them, that they were really stuck to their guns about what they were thinking about. It was interesting to me, like, that the property ones came up so early in the discussion. Like, I didn't think that they would see that x plus y equals y plus x as a property would just jump out at them so quickly. So when we went back to the subgroups, I was really amazed how that category disappeared, because it was, probably like the second category or something that came out, and then all of a sudden that category wasn't up there anymore, and you go, what happened to that? And their confusions were really interesting. So the group at the front here, on all of their papers, they say, well, equations are things that you can solve, and the inequalities are things that can't be solved, which is puzzling because there is a solution. It's just not a single number. But then I think that they might be the only group of papers I saw where they were talking about like the boundaries, and when they got into just examining inequalities, they knew a lot about how that looks like in terms of a graph, about the open circle and it's included or it's not included. So they had a lot of knowledge about that, and so it makes me think how difficult this notion of what it means to solve something is for students. How can we make that more explicit? I mean, it's just something that we sort of take for, or at least I take for granted when I'm teaching. And it also came up when we were looking at these solving for unknown equations with the y equal 2 is different because it just is an answer. There's nothing to solve. So what do those solutions mean? And then it seemed interesting to me, I don't seem to have heard personally a group talk about what the f times 1 equals f is, or the a equals l times w, which to me, at least the area one would have been more obvious than the property ones. So, but I never heard anybody think about how to name that as a category. Or the idea that, you could combine like terms on the equations and on the expressions, because you have the 3x plus 2x equals 5x.
In expressions, you can combine like terms. So I tried to sort of probe that a little, like, is that the only place you would combine like terms? And I think, what really was interesting is how fragile their use of language is. And when you're talking about solving, what does it mean to solve? You can solve some, they were, number of kids were talking about it, but Maya did specifically the idea of open and closed, and that they were saying the variable, I think it was actually this group that said the variable is a solution on the less than or equal to or greater than or equal to, but it's not a solution. So the idea that the value of x, when you set them equal and you solve for that boundary point, is included or is not included. They don't have a sort of way to talk about what solution means. That solution can be a set, that this is the boundary point, and they're starting to, but it takes lots of unscripted opportunities to have to put those words together that they begin to develop a language for.
But I mean, I think that's what was really interesting about the lesson, is that sort of awareness was starting to come more towards the surface. So it did pick at some of those big ideas that you wanted to surface for kids.
Yeah, I think solving is a big one that we haven't really talked about. But what does it mean to solve? That fits with equation or equality and with variable. And, what's it mean to do the math that we call solving? So,
Yeah.
And they were talking about solving. You can't to them solving. Some kids you solve an expression if it can be changed, if the terms can be combined. That's solving the equation. Do you want us to solve that?
The expression.
The expression, sorry.
Yeah, so combining like terms is
solving. Exactly. Solving just means doing.
Right.
Yeah.
Get an answer.
I can do something to it to change it.
Right. So they'll say that expression can't be solved, but that one can be, meaning you could combine like terms.
Yeah.
Whatever that one said. Because they said, well, it doesn't have an equal sign, so we think it's an expression, but you're not combining like terms, you actually have to solve it, because it was like m squared times m to the fourth or something like that. And so there was something about it that made it feel like solving and not combining like terms. And so they had this discussion about, are you solving it or are you combining like terms? Versus 3x plus 1x or whatever. They were sure that was combining like terms, but they didn't see m squared times m to the fourth as like terms. I mean, I think they sort of, I'm not sure they could have verbalized it, but they saw that, well, one's m squared, one's m to the fourth. They didn't see those as like terms, so they decided it wasn't combining like terms, so it must be solving, because you have to like do some calculation to do the, to do those exponent operations.
And they had, I think, a really difficult time with the whole idea of operation. Like, it couldn't fit in the same category if it was adding versus dividing or multiplying versus some other thing. To them, like meant it somehow had to have that same operation.
Yeah.
I mean, that was really one of the first things they always said.
Which is evidence that whatever we're doing through this grade and the previous grade and on back is they're focusing, the salient features of things are whether it's addition or subtraction, that we teach them addition and then we teach them subtraction, then multiplication, then division, then powers, and those are the things they pay attention to, not sort of the more global things.
I think this really pushed them to start paying attention to other things, because when the one person brought up the idea of values, then as you sort of walked around and listened to other groups, they were all picking up on that idea of values, and I don't think anybody reached a solid conclusion about it, but they were all struggling to try to define what that meant in their discussion. So, I mean, I think that's a really good thing, that there needed to be values in there somewhere. What does that mean?